This is a question about transition metals and bonding. It's 9 marks, so pause, try each section, and then review once you're done. Here's parts A, B, and C, parts D and E, and part F. Okay, so let's take a look at part A. We have got hexa aqua copper, ions CuH2O6, and we've also got Cl2. And we want to know the type of bonding between the oxygen and the hydrogen in this compound. Now, it's important to consider that this is a water ligand. There is a dative covalent bond from the O to the copper, but within the water ligand itself, it's straightforward covalent bonding. Why would the chloride ions in this compound not be considered ligands? Well, remember that a ligand will form a dative covalent bond. The chloride is not donating a lone pair to the copper 2 plus ion. Instead, there's an electrostatic force of attraction between the CuH2O6 2 plus and the Cl minus ions. Moving on, an excess of ammonia added to a sample of solution A to form solution B. Now, on this particular one, you can see the equation already. You have got to remember very specifically that with the CuH2O6 plus 2, only 4NH3 will substitute, leaving 2 waters on there. And obviously, we have a secondary product of 4H2O for the ligands that have been kicked off. And you also need to learn the colours. There are many, many observations to learn within this topic. Now we start with our blue solution, but we end up with a deep blue solution. Moving on to part D, we have aqueous sodium carbonate added to another sample of solution A to form a blue-green solid C. Once again, you need to know the colours, but then you need also to be able to recognise the colours and give the relevant compound. And in this particular case, we're looking for copper carbonate. Reaction D was added to another sample of solution A to form a yellow-green solution. So if you've learnt the colours, you're halfway there. Identify reagent D and write an ionic equation for the reaction that occurs when the yellow-green solution is formed from solution A. Well, the identity of reagent D is HCl. That's what's going to take us to the yellow-green solution. The yellow-green solution is CuCl4 2-. To get access to these marks for this equation mark, you've got to remember that you can only fit chloro ligands, 4 of them, around a central metal ion. So we actually change the shape, we change the coordination number. Once you've got that, the equation becomes a little bit more straightforward. On to F, and we want to know why colorimetry cannot be used to determine the concentration of solutions containing CuCl2-. Well, let's start off by writing out the electron configuration for copper, remembering the copper chromium anomaly, where one of the electrons shifts and we end up with 4s1 and 3d10 rather than 4s2, 3d9. But in CuCl2-, we have a copper plus 1 ion, so we lose 1 electron, and we're going to lose 4s before we lose 3d. Now that means it has a full 3d sublevel. Transition metals only act in a transitional way when they have partially filled d sublevels, and that's to allow for dd transitions. Because it's got a full 3d sublevel, it cannot absorb visible light, and therefore it's colourless.